what things were really good about your model, what things were difficult about your model that didn't work too well. Just very quickly, which model were you doing? Is there anything that was particularly doesn't work very well with the water model?
Well, potential difference in resistance is difficult
to show. Okay, so that some of the concepts we're trying to get at don't work too well with the water model. You were doing the bread vans. Which ones did you have problems with? Or were there any in particular that don't seem to work particularly well?
Resistance, we started to stumble on there.
Right, so resistance again is another one. There's always limitations to the models, and the road loop model.
I don't think it works particularly well with parallel circuits.
Right, but what
That
about...
wasn't one of yours on that.
No.
But
You have extended our framework.
Is there anything here that it didn't particularly work well with?
we weren't sure it represented the wire.
The wire, yeah.
Well, it doesn't. The wire isn't there.
And I'd also say, if the pupils don't understand the idea of W equals Fx for energy transfer, then that's what you're relying on for the energy transfer in the road model.
Okay, other than the fact that it simply is transferring the model from my hand to that person's hand. Yeah. Okay, so the CPD, I'm going out of real time and talk about the CPD session here. The CPD session would then spend quite a lot of time exploring some of these in detail, trying to get the teachers to realise that the models do have limitations and get them to think about which one or ones they might present to their students in their lessons. Because what we're also doing is modelling to them a lesson that they could actually make use of. From that discussion, we would then move into much more what do we actually mean by all of these things and how does it link back to energy. And then the sort of final, so having started with, so then the final part of the session would then be to go into turning all of that discussion into what are the formal concepts that we're trying to cover, what's the end product you want from your lesson, and in particular, how do we record those sorts of links and relationships by things such as equations, and which equations might we make use of. And in doing so, we have followed a particular trail of development, which is
go from the concrete to the abstract, really. This thing here, you can see we chose as teachers to fill that section in. And because you chose to fill that section in, you can apply the same principle to any set of models that you like. But the thing that we felt was important was that it should start with the concrete and go on to the abstract. From my point of view as doing a TLC work, I find that teaching electricity is quite unique in one sense, in the sense that you've got different levels, around about 4 different levels of conceptual ideas which you've got. You've got the idea of being able to put the equipment together, which is the kinesthetics. You've got the idea of then what's happening within that circuit, which is the sort of trying to understand what's going on. Then you've got the concepts of using models, which is another more difficult concept up for most students. And then you've got even more difficulty in the sense that you've got to use symbols to represent things. My challenge to my teachers is, when do you introduce what? Is it important to introduce the symbols at the beginning when that's a high level concept? Always work from the easier concepts to the more difficult ones, from the concrete to the abstract. Okay?
that's it.
Okay.